Thanks. All right, so these are the 3 agenda topics that we have. Let me start with the DDoS protection. So let's first start talking about what are DDoS attacks, right? So DDoS stands for distributed denial of service, and it's an attack where bad actors send a large floods of illegitimate traffic to an application or network, primarily using some sort of botnet or to accomplish the disruption. These botnets are primarily comprised of compromised IoT devices and personal workstations and servers that have some sort of malicious software installed, where bot master can control remotely. So the goal is to take down the service by exhausting the application resources or even the resources of a middle box, like for example a firewall or any other network device. Let's say, for example, another deep packet inspection device or something like that. And this can result in poor website or application performance, or can knock it offline altogether. This style of attack is one of the biggest security concerns today because it can costly to your business, to your company, but it's not really expensive for bad actors to pay for starting these kind of attacks. So why should you care about the DDoS attacks, right? Well, any public IP is vulnerable to DDoS attacks, and it's one of the top causes for service availability for large enterprises. DDoS attacks, if they are not mitigated, they can be costly to the organizations again. And due to the loss of customer interaction with your backend, with your website, or even from dynamic resources scaling to handle the volume of new traffic coming in. So that might cost for your company. Next, we have we're going to talk about some DDoS attack types, right? So to start with, let's talk about the volumetric attacks, right? So these attacks use a massive amount of traffic, which saturates the bandwidth of target victim systems. And these volumetric attacks are easy to generate, because either using DDoS or some higher services, the attackers they can employ simple amplification techniques. It creates them such high quality quantity of traffic that can be completely block access to the end system, like for example a website or any other service. And these attacks are measured in bits or packets per second. And some examples of these attacks are, let's say, ICMP flood, IPsec flood, or UDP flood. Then we have the protocol attacks, that are, also known as state exhaustion attacks. And this type of attack causes a service disruption by consuming all the available capacity of your web application servers, or the capacity of some other intermediate resources and devices you have in the data path. It abuses flaws on the network layer, exploiting protocols like ICMP and IPsec, and falls on the transport layer, exploiting flaws in the TCP and UDP protocols. The most common example is the TCP SYN flood attack. This attack exploits the TCP handshake by sending a target many, a huge amount of TCP SYN packets or initial connection requests with spoofed source IP addresses. So the victim machine, right, the target machine, then responds to each one of these connection requests and keeps waiting for the responses to finalize the TCP handshake. This response never comes, and then the connection is staying open state, waiting for a response. And due to the number of requests, it causes the system to exhaust all the resources available and become unresponsive. And then last but not least, here we have the resource attacks, or the application layer attacks, which are layer 7 attacks to target the backend servers. And the goal of these attacks is to exhaust the resources of the target application and abuse flaws and vulnerabilities on the application itself. So let's say, for example, targeting how web pages and web servers handle HTTP requests. A single HTTP request, is simple to execute on the client side, But on the destination side, on the target side, it may demand a lot of process, because sometimes the application needs to load files, run database queries, and some other integrations with third-party systems. This type of attack is a challenge to identify and defend against, because the traffic seems to be very legitimate, and it can be difficult to be sure when it's malicious. So Azure DDoS by itself, it doesn't protect against layer 7 protocol attacks, and we must use the web application firewall in conjunction with the DDoS protection plan. So you can use it, via Azure Application Gateway with WEF, or you can also use it with Azure Front Door with WEF in the global SKU. So today we have two offers for the Azure DDoS protection plan, right? The first one we are calling Azure DDoS Network Protection, which is formally known as DDoS Protection Standard. And this plan covers up to 100 public IPs within your entire tenant, and more with additional cost, right? We do have like 6 great benefits when using the DDoS Network Protection plan. The first one is that the DDoS utilizes the combined throughput of the Azure Global Network to mitigate large DDoS attacks. And the mitigation will start when, at the specific region where the target resource and public IP address is located at. And it will expand to source ingress regions dependent on the scale of the attack. If the single region can handle the mitigation alone, it will do so. Then we have the adaptive tuning. So for the adaptive tuning, we have the intelligent traffic profiling learning your application traffic over time. And then it selects and updates the profiles that is most suitable for your specific application. The profiles adjust as time changes, and the traffic changes over time as well. Next one, we have the attack analytics and metrics. So summarized metrics from each attack are accessible through Azure Monitor, and you can also get daily reports in a matter of minutes, 5 minutes increments during an attack, and a complete summary after the attack ends. So this data will be available through the logs, and you can also stream your mitigation flow logs to Microsoft Sentinel, and or another offline SIEM system for near real-time monitoring during an attack. Then we have the integration with Microsoft Defender for Cloud and Sentinel, where you can integrate with MDC, where the alerts will automatically trigger during an active DDoS attack. And with Sentinel, you can use the DDoS workbook that's built in, to analyze the attacks. And you can use the newly created DDoS solution for Sentinel that we are going to discuss today, that will automate remediation response for the Azure Firewall to block malicious source IPs from secondary attacks during an active DDoS attack. Next one is the DDoS rapid response, where during an active attack, the Azure DDoS Protection customers have access to a dedicated team, the DDoS rapid response team, who can help with attack investigation during an attack and post-attack analysis. And last but not least, the SLA guarantee and cost protection, where when you are using the Azure DDoS Network Protection and you get are under an attack, and then this attack increases your cost with resources scaling and some kind of losing money because of that attack, right? So you can receive the data transfer and application scale out service credit for resource costs incurred as a result of this documented DDoS attack. Then next one is our Azure DDoS AP protection SKU, which is currently in public preview. And it has pretty much all the same features that the network protection SKU. And the difference is that we don't have the SLA guarantee and the cost protection. We don't have access to the rapid response team. And the difference is mainly that instead of creating a plan and associating that plan to the VNets that you want to protect, you are going to protect specific IP addresses. So instead of paying the amount you would pay for the network protection plan, you would pay for per IP protected. Okay, the next one we have the Azure Firewall, right? So what is the Azure Firewall? It is our cloud native and intelligent network firewall security service that provides the best of breed threat protection for your cloud workloads running in Azure. So it's fully stateful. It's a firewall as a service, with built-in high availability and cloud scalability. It provides both east-west traffic inspection and north-south traffic inspection, and it also provides outbound net and support for inbound inbound DNet rules. The Azure Firewall can be configured during deployment to span across different availability zones, increasing your SLA to 99.99%. And with the cloud scalability, Azure Firewall can scale out as much as you need, to accommodate changing network traffic flows in your environment. And additionally, all the events are integrated with Azure Monitor, allowing you to archive logs to storage account stream, the events to Event Hub, and also send them to Azure Monitor logs and use Log Analytics Workspace to, query and to play with the logs. The Azure Firewall today is offered in 3 different SKUs. Actually, the first one is the basic SKU, which is not public preview anymore. It went GA recently. The next one is the standard SKU, which is intended for enterprise and government organizations, and then the premium SKU that offers some premium features like, for example, TLS inspection, IDPS, and URL filtering. And it also offers higher throughput and bandwidth support. All right, so when we talk about Azure Firewall, we think about 3 different methods or 3 different ways where we can implement this service in our environment, right? So we can deploy it, directly in a virtual network using traditional hub and spoke method. And in this instance, the Azure Firewall lives within a centralized virtual network where all the networks with workloads will peer directly with the hub virtual network, right? And it allows, for inspection within the same virtual network, between spoke virtual networks, traffic to the internet, and additionally, traffic to and from on-premises, branches, or another cloud provider using VPN or Express Route Circuit. Then you can deploy the Azure Firewall into a virtual WAN hub, transforming that hub in something that we call virtual secure hub, and providing the same flexibility of inspection from a virtual network deployment, where with the added route management configuration available in virtual WAN. So in this environment, you don't need to manage route tables to force traffic to Azure Firewall, as the hub will do this for you as part of the service. And finally, we have, we can also deploy the Azure Firewall in forced tunnel mode, where, let's say, where further inspection or internet breakout is handled by a different firewall or third-party firewall that's located, on premises or elsewhere. So you need to send the traffic to a next firewall to do some additional inspection, and that way you can deploy it by using the forced tunnel mode. All right. So now we went through the overview of each one of the products, and that's important to start discussing the new solution, right? For the new DDoS solution for Microsoft Sentinel. So this new solution has been released last month. We do have a blog in our tech community blog which explains what the solution does and also gives you the steps that you need to deploy and start using this solution, right? So when we the main idea of this solution, right, we see customers that are using DDoS protection services to safeguard their applications hosted in Azure against DDoS attacks. And Microsoft Sentinel and Azure DDoS protection services, they can offer a nice integration to easily ingest DDoS protection logs and view and analyze this data in Sentinel, to create custom alerts, improve their security posture, investigation, and response processes. So specifically, customers can correlate the DDoS smokescreen attacks with events from different sources to detect advanced attacks, such as, let's say, data theft, and automatically block them, right? We always look to, for better ways to allow the customers to achieve more, from Azure DDoS Protection and Microsoft Sentinel. And then this new Azure DDoS solution for Microsoft Sentinel uses the Azure DDoS Protection logs to pinpoint offending, DDoS sources and to block them from launching other sophisticated attacks such as data theft. With this new solution, customers and admins can now leverage Azure's DDoS security signals to identify potential bad actors and to block any new attack vectors in other security products. So, for example, the solution works seamlessly with Azure Firewall, and then if you want to integrate that with some third-party firewalls as well, you can do it. For example, you can do it, for Palo Alto, for Checkpoint, Azure WAF, and some other products. And then giving customers the, more comprehensive protection against cyber attacks. So in this diagram here, we can see how the solution works. So the first thing we see, the number one here, the DDoS attack starts, and then the DDoS emit the logs to the Sentinel, and then the Sentinel detects the bad sources and trigger the automation. And what the automation does, when the automation is triggered, we send the IP remediation to the Azure Firewall to start blocking that IP address. And then we see the bad actor up here trying to run some data theft, and the IP being blocked by the Azure Firewall here on step 6. So this is pretty much how the solution works. Saleem will start, driving you through the demo environment that we have, showing a little bit more about this solution. Saleem, over to you. Actually, just one other thing before sending it over to you that I forgot to mention, right? To be able to work with this data and ingest the logs into Sentinel, we need to enable the logs in the public IP addresses that are protected by the DDoS plan. And to do it, you need to create a diagnostic settings, in each one of the public IP addresses we have, and then make sure that we are selecting these 3 categories here. So DDoS protection notifications, mitigation flow logs, and mitigation reports. Over to you, Saleem. Thank you.
Awesome. Thanks a lot, Gustavo. So let's start with the demo part. So for this demo, I will show you how the solution looks like, the specific playbook, the automation, we have everything configured. I will show you also the DDoS simulation attack. So we will simulate DDoS attack. We will see how it will look like, the protection we get, and also we will see how the solution works, the specific IPs. We want to see them also in the IP group and how they're protected in Azure Firewall. And in our case, we will use Azure Firewall, but later I'll explain that with this solution, you can use also other vendors. So let's start. The first part I want to start with is actually not Microsoft Sentinel, but I will go to our DDoS protection just to make sure that we have it enabled. So I have this plan created. And in this plan, if I go under the protected resources, and under the VNet, you will see that after a bit, it will show my VNet, which is protected. And what this means is that all the public IPs that you have under this VNet are protected with this DDoS plan. So it doesn't matter if it's firewall, application gateway, bastion, anything like that has a public IP in this VNet will be protected by this DDoS protection plan. In our case, I will have a bastion host, and you can see here. So this is the public IP that the bastion host is using, and let's jump to this public IP. Now going to the same point that Gustavo mentioned, and this is a very important one. In the public IP, an important part is having the diagnostic settings enabled. So in our case, you can see here, I have this diagnostic settings, and basically this is logging, right? So if you don't have this enabled, you are still protected, but you can't see anything, and the solution doesn't work. So I will go here, edit the settings, and you will see here that I have all the logs, which are DDoS protection notifications, which shows when an attack happens, DDoS mitigation decisions. And this is the most important one for us for this solution, because we will be using the analytics to actually check the logs from this category to see which ones we want to add as a source IP. And then we have the reports of DDoS mitigation, which is like an aggregated view of the mitigation attacks. And this is really useful, especially if you're using also the DDoS workbook. Now you can see that I'm sending all of these to my log analytics workspace. I call it Saleem workspace, and I will use also the Sentinel for this workspace to run the analytics and also the automation. Now that we know that we have this bastion with this public IP protected with DDoS, and we are also sure that we have the diagnostic settings enabled. And just one note here before going forward, the logging, we have also Azure policies, which can enforce that all your public IPs have the logging enabled. So this doesn't have to be done manually. If you have tens or hundreds of public IPs, you can just have a policy that makes sure or enforces that the logging is enabled. So the next part, let's start with the simulation test. So for this demo, I'm going to be using the Breaking Point. This is one of our simulation testing partners. We have 3 testing simulation partners right now. The first one is Breaking Point. Then we have Red Button. And latest, we had the Red Wolf, which we've added recently. So you can use any one of them. So for this demo, I'm going to be using the Breaking Point. Now here, the target IP address, I already have the IP address, and let's just go back to our IP address just to make sure. So let's go to overview, and we can see here, so it's the same public IP that I'm going to be using. So let's go back to the Breaking Point. For this attack, I'm going to be doing it on port number 443 on HTTPS, TCP sync float. It's going to be the test size. I'm going to be 200,000 packets per second, and we're going to be using 8 source IPs. And this is very important information that I will show you later. And the test duration will be 10 minutes. So let's start the test. Now, the first thing that Breaking Point will do once I click on Start Testing, it will validate. Basically, validating it will check if in the if I have this specific subscription of Azure validated in this subscription. So, and I'll show you here. Otherwise, it will not start the testing. So I have here Azure subscriptions, and you can see here I have it authorized. So it's authorized to do the testing on this subscription, and I have done it. And now it's queued, and the test will start in a bit. It will start the DDoS attack, and it will be running for 10 minutes. Now, while the test is ongoing, I will show you how the Sentinel solution looks like. Talk a bit about the playbook, how it interacts with each other, and how it will also look like in the IP group. And then we can go back here and see the results. So let's go to our Microsoft Sentinel. And the first thing we want to start with is data connectors. So let's go and check our solution. So let's go here and search for DDoS, and we will see Azure DDoS Protection. Now here on the right, you will see that we have, for this DDoS connector, we have 1 workbook, 2 queries, and 2 analytic rules. For this solution, what's important to us will be these 2 analytic rules, which are the new ones that we added recently. And I will show you now what these are. So I'm going to go to analytics. And under analytics here, we should be able to see that I have it already enabled, my active rules. You can see that I have the this one enabled, which is the DDoS attack IP addresses. But let's go to templates first, and let's have a look at the rules themselves so we can understand what they do. So let's search for DDoS, and you can see, so this is the first one, this is the one I'm using right now, and this is the second one. And you can use either of them, both, like depends on your needs. So let's check the first one. So the first one, it looks at the percentage. So basically it identifies the IP addresses that generate over 5% of the traffic during the DDoS attack mitigation. So during this attack that I started here with the breaking point, it will, if a public IP generates 5% of all the traffic during this attack, then it will add it and it will show it as an alert. And you can see here in the query that if you want, you can of course also change this 5%. So it really depends on your environment and what you want to achieve, right? The one we set here, we see that works fine, was 5%, but this of course really depends on your environment. So this is the first analytic rule. Let's have a look at the second one. The second one uses the PPS, so packet per second. So the first one uses the percentage, which is 5%. This one will look at the packet per second that comes from the IP addresses, and if one of the IP addresses generates over 10,000 packet per second, which is huge amount of traffic from just one source IP coming to your public IP, it will also add it as a source IP. So these are the analytic rules. Let's have a look at the specific automation and to see how it also connects to the playbook. So the analytic rules, they will look at the Azure diagnostics. They will look at they will find these source IPs, and they will create entities for them. Now we have the entities, we have the source IPs. Now what we do with them, right? So we have here the automation. So DDoS IP automation that I've created. Now this automation, what it does, when an incident is created, so once the analytical rule creates an alert, and then we have an incident because of that, that incident will have the source IPs. When an incident is created, and here specifically, I have the DDoS attack IP address, which is the one I have enabled, then the action, it will run this playbook. So the playbook I'm using here, and this master playbook is available in GitHub, so you can download it and you can also use it. Is a master playbook for IP remediation, and this is a master playbook, which means it will have a nested playbooks, and I will just show you in a second. Now, after we have the incident, it will run this playbook. It will the playbook will take these source IPs and it will add them to the IP group. And I will show you now how it does it. So this is basically just the automation. It's pretty simple. You have the incident. It starts the playbook, right? Now let's have a look at the playbook itself and let's see what it does to understand. So here's our master playbook IP remediation. So, and I've said earlier that this solution doesn't just work with Azure Firewall, but also works with other vendors. And here you can see you have Forcepoint, you have Fortinet, FortiGate, Meraki, Panos, Palo Alto, and also Azure Firewall, right? So in our case, I'm going to just show you Azure Firewall, but if you have other NVAs, other firewalls, you can also use this solution to proactively protect your workloads from these malicious IPs. So what it does, once, as you can see here, the Azure Sentinel incident creation rule was triggered, it takes the IPs, which are the entities, and it will add them to, or it will start the specific playbook. Now, each one of these is a nested playbook. Because for this demo, I'm going to be just using Azure Firewall. I will just show you the Azure Firewall nested playbook. And let's go here. So this is the nested playbook. This is the one I showed you there for Azure Firewall. This one is called Azure Firewall Block IP Nested Remediation. And what it does, it will take those entities, those source IPs, and it will add them to the IP group. And you can see here, I've tested a few times, and you can see that it succeeded, which means that it successfully added those source IPs to the IP group. Let me refresh it here just to see if there's anything new. And you can see here that we have a new one, and this is the new test that we just did now recently. So it's already working. The automation already run, and it already added the IPs. And I will show you in a bit how they look like. But before doing that, let's go to the Logic App Designer and show you how it looks like the playbook itself. So basically, from the master playbook, it will send an HTTP request to receive it here, and it will have also the IPs and everything. Now this playbook, what it will do, it will create a variable for the IPs. We will have also a variable for the IP group name, and you can see here, this is the IP group that I'm using for the Azure Firewall. And then it will add them, and we will go to the scope, and you can see here it will add the specific IPs. It will get the IPs and it will add them to the IP group. Now, once you have this, so this is the playbooks, this is the automation, and we can see that it already kicked in. It's all, once you have it configured, it's all automation. So you don't need to do anything else here. You don't need to change anything. It's automated. Now let's have a look at the test itself. So I see here, for some reason it's still cute, but let's go and check our data. So I'm gonna go to logs. So this is the workspace where I'm sending all the logs, and I'm gonna run this DDoS protection notification. So this will show me if there was any attack, if there's a notification for a mitigation that started, and let's run it. And we have two other categories, as I showed you earlier, and perfect. So you can see here that at this specific time, so this is when we started the test, and we can see here that, so this is the mitigation stopped. Let's go to this one, and this is mitigation stopped, and this will be the started one. And yep, here we can see it. So this is when the mitigation started. This is when we started the attack, and you can see here the notification for it that there was an attack from for this public IP, and this is the one that we did the attack on, and we had the threshold. The threshold was met, and the mitigation started. So we have this attack, and we know that there was an attack, right? So let's go back to our Sentinel solution, and we will go to incidents. So under incidents, and here it is. You can see it. So this is the attack. This is the incident created from the mitigation. And you can see here, so we have 8 events. And if you remember when I did the test, I was using 8 source IPs, and as you can see here, we have 8 entities. So these are the 8 source IPs that were detected. And I used here the analytic rule with over 5% of traffic, right? So it created the alert. We have also the incident. Now, the logic, of how, so once this was created, it triggered also the automation, right? So the automation started the playbook, the master playbook, send this over to all of these playbooks. We're only using the Azure Firewall one, right? So the nested playbook here, as you can see, it successfully got the information, the public IPs, and it added them to the IP group. Now let's go to the IP group, which is the final destination where we have the IPs. And we go here, and we can see the public IPs. So all the public IPs, the 8 entities that we had, are added here, as you can see. And now so you're saying so how you can use this IP group, right? So since now you have them here, this IP group, I mean, the best recommendation or best way to use it, of course, is to have it as a deny in your Azure Firewall policy, right? And I will show you now how it will look like. And you can see, so here, rules using this IP group, we have this resource name, and we have this firewall policy. So let's go to this firewall policy. And under network rules, you will see that we have a few rules, and the one we are interested in is the third one. So deny access, block IP, and as a source, we use this IP group. So let me open this one. And you can see here, the source IP group we're using, this is the one that we are adding all the source IPs, that the malicious source IPs we detected using the DDoS solution from Sentinel. and we've added them to this public IP. What we're doing is that for any, here, any destination any destination IP addresses, protocol port denied. Now, this is the configuration that we have here. You are proactively protecting, yourself from any further attacks from using your Azure firewall or any other firewall. At the same time, you can change this to how you need it. You can have a specific, for example, if you want different destination, just like, you want to protect just those destination IPs or specific ports or protocols. And this is basically how it works. This is the solution from the beginning to the end. Once you configure it, it's all automated, so there's nothing to needs to be done anymore. Of course, you should always monitor it and see, like, how many public IPs you have added, or if there was anything that goes wrong. Yeah, so this is the demo. Next, I think we can start the Q&A and see if there was any questions that were not answered or some clarification that we can provide.
Sure, yeah. The team's been great with answering questions. We do have a few that are worth bringing up. The first one is, so do you need to use Azure DDoS if you implement Azure Firewall?
Yeah, so if you need Azure Firewall, if you need Azure Firewall if using DDoS, right? So Azure Firewall protects you from layer 3, 4, and also layer 7 from different types of attacks. And you can use, for example, IDPS. You have also threat intelligence, TLS inspection. However, Azure Firewall still has a limited resources, and it runs on specific load balancer, and it will if you have, for example, if you were under DDoS attack, what will happen? It will your Azure Firewall will scale out. You will either it will reach the maximum, it will start dropping the packets, or simply it will just forward the traffic, so nothing will happen to you. However, you will get extra costs because of that scaling out. So Azure Firewall by itself, it doesn't provide DDoS protection. However, the public IPs that you have on the Azure Firewall, you can enable DDoS protection on it. And once you enable it, then you will have DDoS protection at layer 3 and 4. And you get also the protection from the firewall as IDPS, network rules, DNS, threat intelligence, and all of this. So our recommendation is always to use, of course, both of them, DDoS and also Azure Firewall.
Great, thank you. The next question we have is, what is the recommended architecture for DDoS protection? Should the Azure Firewall be deployed in front of DDoS protection, or WAF is above the DDoS protection?
Yeah, so from perspective of the architecture, right? The DDoS protection, it's not a resource by itself where it's not like a device where you enable it before, like on premises you have a certain device, you enable it before, like the firewall, or after it, right? In Azure, when the DDoS protection, you can have it as a plan, and you protect the public IPs, so you can enable it on your specific public IPs. Now, the Azure Firewall, you can have the public IP there. Once you enable DDoS, from architecture point of view, the DDoS protection is before the Azure Firewall. So if there is any attack, the malicious traffic will not get to the Azure Firewall. Now, from the WAF, depends, of course, so if you have application gateway, WAF, then you can have a public IP, on it, and it's basically the same thing, where you protect the DDoS protection on your public IP, and you get the protection before it reaches your WAF, right? And of course, for WAF, for front door, that's a different story. It's a CDN, so it doesn't really have a specific public IP, right? But from the architecture point of view, when you have a resource, the public IP, the DDoS protection always comes first.
Great. The next question we have is, if a storage device or virtual machine or PaaS component has its own public IP address assigned, do they get protection from Azure DDoS?
Mm-hmm. Yeah, so right now it's not possible. So if you have a PaaS public IP, it's not supported. Of course, this is something that will come hopefully in the future. Right now, it's not supported. However, the recommendation is always to reroute the traffic through like an application gateway or Azure Firewall to get also the DDoS protection. And just also a note here with the APIM. So APIM before it wasn't supported. Now, if you're using APIM and if you want DDoS protection, then if you're using APIM with the VNet settings, then you can enable also DDoS protection, and you get DDoS protection at layer 3 and 4 for your APIM traffic, API traffic. Yeah.
Great, thank you. The next question we have is this configuration advisable to use in Power Pages / platform apps?
It really depends on the architecture here, right? So it really depends on where you have what you have as internet facing, how you have the traffic routed, and what you're using. I can't give you a concrete answer here, honestly, without looking deeper into the architecture. But of course, as I said, like the best way is really looking at the resources that that support Azure DDoS protection, and and making sure like to have that resource before it goes to your workloads.
Great, thank you. The next question we have is, does this work for apps that are not hosted in Azure?
So yeah, this one also it depends, right? So I can give you an example of where it would work. So we've done recently also another public webinar on how to protect your, for example, AWS resources using Azure WAF, right? So in that case, in the case in case you have like resources like for example, even if you have resources like on-prem, right? If you have an application gateway that receives the traffic and then it will send it to your workloads, which is like maybe in some other cloud, then yes, you can use the DDoS protection, and you can enable it on, for example, in this case, like the application gateway, and you will get the DDoS protection.
Great. The next question we have is, does the integration with Sentinel and SIEM part also work with IP protection SKU?
Yes, totally. So basically, like for this integration, all you need is the logs from the mitigation, right? So the ones I've mentioned earlier, which are the decision logs, which will show all the packets if they were denied, or if they were not malicious traffic and they were forwarded. So those category of logs will be the same also in the new SKU, in the IP protection SKU. So yes, the short answer is yes. You can use this solution also for the IP protection, and the same thing also for the network protection.
Great. And then the next question is, can you put an Azure App Gateway in front of a storage account?
I don't think it's that related to our session today, regarding DDoS. But I mean, I'm not an expert on that, so I can't really give a concrete answer.
No problem. The next question is, to use the playbook shown today, do they have to use network DDoS? Is creating a plan required?
So you can either use the plan. So we have two SKUs for DDoS protection. We have the network protection, which is a plan. It gives you 100 IPs, that you can use, and anything over that 100 IPs, there's like an extra cost that you pay for it. So that's the first SKU. Or you can also use it for the new SKU, which is IP protection SKU. So the Sentinel integration works for both of them, and you can use any of them to have this.
Great. That seems to be all the questions that we have. So I'd like to thank you, Gustavo and Saleem, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/AzureNetSecFeedback. Thank you and see you next time. Goodbye.